Hello. So I did a lead code contest today. It's the weekly contest 492. I was only able to solve one problem. And if we check the ranking I got, why is it changing? I don't know if it's the final ranking because earlier when I saw it's something else. I got this rank of 20,000 in a 42,000 participation contest. Yeah, so I'm pretty angry about it. So today is about channeling that anger into something good. So I have a lot of assignments pending, though I did them. How do I say? Though I did them in my preparation, I haven't finished them in the platform. So I'll be going to finish them now. And here we have a way to track it. I'll just show that. Just a minute. Why is Codeforces not opening now? Hmm. Okay, so I am here in my journey, and you see, like, I am at 57%. I still have 67 problems to solve. I'll be doing a lot of them. I want to keep using this to focus in short bursts and take a break in between. So let me just start. So I did till sort one, and this is arrange the numbers. Yes. You are given a single integer and construct an array of length and containing the integers from 1 to n, each exactly once in the following order. Construct an array of length and containing integers from 1 to n, each exactly once in the following order. The first line contains a single integer t, the number of test cases. Each of the next t lines contains a single integer n. Okay, got it. Well, so here we have one test case and the test case value for n is 5. We want to have an array in this format, which is the odd numbers are in increasing order while the even numbers are in decreasing order. Let me connect my other laptop so I can share the screen and write the approach, etc. Give me 1 minute. Sharing the screen. Just a minute. One minute. Yeah, I hope it's visible. Yeah. So if we were given 5 as the input, the output must contain, let's say, like, let's first write the numbers normally 1 2 3 4 5, but how we need it is we want the odd numbers in the first three places, and then the even numbers, but the even numbers are in descending order. So that's how we want it. So as we have 5, we can first think of starting from 1 and going till um, whatever odd number we can reach to. So even when the input is 6, the maximum odd number we can have is 5. Even if we have 8, the maximum odd number we can reach is 7. So it's like we can first write one loop to do this, and then we can start from the biggest even number possible. So something like when we have 5, the biggest even number possible is 4, and let's say when we have 8, the biggest possible even number is 8 itself. If it's 6, 6, then go down by 2 till we reach 2. So that's the approach. So we have to write one for loop for odd, which is increasing, one for loop for even, which is decreasing. So this is the approach. Let me just write the code for it. And once we do it, we need to repeat it for these many test cases. First, let's write what we have to solve for one test case. I just took the boilerplate code. Actually, I'll write here the void solve function. This is where I'll actually do the actual solution. Ignore this part for now. I'll anyway actually won't need this. Yeah, I'll delete this. This will think of it later, but let's do the actual solution here. So for every time we need to take an input n, and ideally we want to generate the array, right, in that certain format. We'll do that. So as I told, we'll start with odd numbers, and if we see this is the number of test cases, and each of the next t lines contains an integer in the range of 1 to 10 power 4. So like whatever number we get here is going to be between 1 and 10 power 4. uh, it won't be 0, it's starting from 1 definitely, and it's going to be a maximum of 10 power 4, right? So um, I can create a variable odd equal to 1 because that's the starting odd number, while odd less than or equal to less than n. What I'll do is see out odd with a space, and I'll increment odd by 2. Let's see how this works. I'll comment all of this and just call the solve function once. So we are just testing out here, nothing fancy. See out odd. Okay, my bad. I'll give 5 itself. You see, we are getting only till 3. I'll make this equal to 5. Okay. We generated the first part. Let me test it out for 6 also. Let's see what happens. Okay, this makes sense. Let me test for 8. This is cool. We were able to generate all the odd numbers. Now it's time to figure out the even number. So mm, if n is even, then it's going to be the maximum even number. If n% double equal to n% to double equal to 0, e equal to n, else n minus 1, e equal to n minus 1. But before it, we need to declare if int eve. You get it right. Like earlier when we checked for 5, it's going to be 4. Whereas if it's an even number like 6 or 8, it's going to be the same even number. So while eve greater than 0, because we definitely don't want 0, or we can also write eve greater than or equal to 2. We can see out eve with a space and decrement eve by 2. So we get the next um, small odd number, which is like if it's 8 now, next it's going to be 6, next it's going to be 4, then 2. Then finally it should stop the loop. And finally, after printing all this, we can do a cout and L so that for the next test case we can do it. Let me call solve 2 times and give an different input each time. What's in our test case? I'll give 6 and 7. First 6, 1, 2, 3, 5, 6, 4, 2. Yeah, that's the one. If we give 7, 1, 2, 3, 5, 7, 6, 4, 2. Makes sense. So now we wrote the solve function correctly, but we still have to do this part, taking the test cases and actually calling the solve function each time. So I'll just do input int t, take its input c in t for int I equal to 0, I less than t, running the loop t times, I plus plus solve. That's all. So this takes care of, this solve function takes care of inputting and solving it by printing the required series. Let me just test it out before submitting. I'll give this input dot slash here dot out, paste. Yeah, makes sense, right? We have it exactly how we need it. So I'm pretty confident with this. Let me submit the code. Instead, I'll just copy paste. Submit. Nice. Let's continue. Before that, arrange the numbers. Oh, I didn't write the last problem I solved yesterday in the sheet. Let's continue. Swap alternate. You are given array n of size n. Your task is to swap every pair of alternate elements in the array. The first line contains a single integer t. The number of test cases. Each test case consists of two lines. The first line contains an integer n, the size of the array, and second line contains n integers. Yeah, that's the actual elements of the array. It is guaranteed that the sum of n overall test cases doesn't exceed 10 power 5. Okay. For each test, print the modified array after performing all swaps. Okay, let's understand this. Let me write the input and then share my screen. 9 3 6 12 4 32 and another test case for 1 2 3 4. Yes. So here the thing is, one second. Yeah, I'll just expand this. So here what we need is, in this given array, we need to swap each element with its next one, and we need to keep doing that. This will be our result array, and here in this case 2 1 4 3. I'll just leave it like this. Yeah, you see, like, these are our outputs: 2 1 4 3 3 9 12 6 32 4. And what happens if the n is odd number? Do we have an example of that? Yes, we do. the last number remains the same. So let's take a smaller example for ourselves. Let's say it is 5 and we have 2, 51, 13, 19, 12. Here we have 5 inputs, right? So we do the swap 51 2, we do the swap again 19 13. This remains as it is because that's there is no pair element for it to swap with. So how can we do this? I am thinking like we'll write um, the similar for loop I equal to 0, I less than n, but instead of I plus 1, what we'll do is I plus equal to 2. In this we'll swap array of I comma array of I plus 1. So what happens in this case? I become let me write down these are the indexes. So I is 0 first, we swap 0 and 1. Indices. So then we move I by 2, so I becomes 2. We swap 2 and 3 based on this. Next I becomes 4, we swap 4 and 5 because by this line. And finally what we do is we just run the same the classic loop of incrementing by 1 and just see out everything with a space. I think that makes sense. Let's code this. Okay, what happens if we have another element? Let's say we have a sixth element called 9. I mean, the index is 6. Now the I is 6. I less than 7. What's the number of elements here? It would be 7. Wait. Maybe I need to change the condition because here if I just compare I less than 7, 6 less than 7, it will attempt swap again in this case where it's odd. Probably I need to check I less than n and I plus 1 less than n because only then we can swap. Yeah, I would change my condition to this. Whatever I wrote perfectly works fine for even, but it doesn't work for odd. So what we must do is update this to I less than n and I plus 1 less than n. Or actually, we can just check I plus 1 less than n because that would definitely mean I less than n. Yeah, so we'll code this swap alternate. Now this is also having similar test cases like before. We'll follow the same approach of solving this once and then in the solve function and then just calling it. So we took input of n, create an array of size and take its input. C in a of I. Okay, that's done. Once we have the array, what can we do? We can do swap for int I equal to 0, I plus 1 less than n, I plus equal to 2, swap of a of I comma a of I plus 1. Then what we'll do is just copy this same thing, but what we do is see out a of I, and after this whole loop is done, just see out end line. I think that's fine. Let's see. Clear G++ swap alternate dot slash a dot dot. Let me copy the input. I'll use this because it has both even and odd. Okay. 3, 9, 12, 6, 32, 4, 11, 5, 19. We have it in the same place. 1, 2 became 2, 1, 3, 4 became 4, 3. This is exactly how we need it. Let's submit this. Swap alternate. Yeah. Yes, that's accepted. Now I'll take this short break. Before that, let me update it in my sheet because I tend to forget that a lot. Swap alternate. I'll take this break. Hello, hello, hello. I'm back. Let's start this again. So this is done swap alternate. Let me close this. Next one is missing number. You are given an integer array of size n where n equal to 2m plus 1. In the array, exactly m numbers appear twice and exactly one number appears only once. Your task is to find the and return the unique number. Your task is to find and return the unique number. Mm, okay, this can be better understood with an example. Let me write down the test case and share my screen. 7 2 3 1 6 3 6 2. This is one test case. Let me take this one with 5 2 4 7 2 7. See, if you see, like, this is an odd number, this is definitely an odd number. There is no chance that we are going to get an even number. Even that's mentioned here and is always odd, because this is classic template of an odd number, right? This can't be even at all. Okay, going here, you see, in this, if we consider 2, we have one occurrence here and its second occurrence here. If we consider this 3, we have its first occurrence here and second occurrence here. If we consider 6, we have third occurrence, I mean the first occurrence here and its second occurrence here. But 1 is that only lonely thing that doesn't have another occurrence. This is what is our answer. Similarly, here for 2, this is the first, this is the second. For 4, unfortunately, this is the only occurrence, and that is our output. For 7, this is the first and this is the second. So what I'll do is, first I'll loop through my entire array. 2 3 1 6 3 6 2. I'll pick one. Now let's say this is the focus. I'll go through the entire array once again and count the number of occurrences of this. Actually, I think we already did a problem, right? Count occurrences, yes, we already did. So what is this? This is a code to find out if a given number is um, count. We are giving the number of times a particular number occurred. Okay, I now this becomes a lot easier. Now what I'll do is, I'll call the count occurrences of that array and this particular number. In this case, this is array of 0. So, and if we want to generalize it, array of I, because in the for loop, each element is going to be represented as array of I in each loop, right? For So whenever this is going to be equal to 1, we'll just return that array of I. That's all, nothing else. I mean, print it. So it's just that we are taking each element from the array itself and counting its occurrences in the array. That's all, nothing else. So whenever that is equal to 1 and only there is one element, that's going to be our answer. So we'll be make use of the count occurrences, and then code this. So what is this problem called? Missing number. Missing number dot cpp. I'll take this code from count occurrences. As we have multiple test cases, I'll do this classic solve thing. Here, what should we do? Take a number and input of an array, right? Int n. And we this code is for taking input of the array. Once we have taken input of number n, you see, till here all I'm doing is taking input of the size of the array and then taking input of the array. That's all. um, so this is the actual code to count the occurrences. I'll paste it here, but we need to do that for every element in the array. So how we'll do that is, I'll write another loop, int p equal to 0, p less than n, p plus plus. I'll nest it properly. Now here the x would be array of p, because we are checking that element, right? And array of I represents, or for clarity, I'll write int target equal to array of p, and I'll just write target here. So whenever, see what this inner loop is doing is, it's going through the whole array, and whenever the current element is equal to target, it's incrementing the count. And whenever this loop is done and we move on to the next one, we are resetting the counter. So what happens if c double equal to 1? Yeah, that's the condition, right? Like there is only one element, um, where the count is 1. We'll just see out that see out array, the target. We can just see out the target and end it. We can also break this loop because we are done with this. Actually, I can do this return. As it's void, we don't return anything. Just writing return statement would get the control back here. So here we need to input the number of test cases and just call the solve function those many times. For int I equal to 0, I less than t, I plus plus, c in, not c in, solve. Let me test this out. Missing number. I'll first input this and check. Oh, my bad. Dot slash a dot out. Paste. What's the output? 1. Makes sense. Let's see here. Yeah, we got it 4 and 10. So, see, this is just for handling the test cases, but the actual work we are doing is taking input of the length and then the array. Now, by this line, we'll have the complete array filled. This is the actual core logic we have written, that uh, we have written a loop to go through all the elements of the array. At each loop, we are picking one target of the array and basically counting how many times we see this element in the same array. If we see it only once, we print it and come out of this whole function because that particular test case is done. So as in, like, when this particular test case runs, you see we t will be 2 and we'll call solve for the first time. It takes input of this 5 and then this array. First it counts number of times we are getting 2, that will be 2. So it will just continue. This if case won't even trigger. Then this target becomes 4. Then we get the count as 1 and that's the reason we get into this if loop, and we'll just print this 4 and get out of this solve function. Then we come back to this for loop again. As this was 2, this loop has to run once again, so it calls the solve function again. Now again it takes this another input where n is 9 and this whole array is the this array which we took as input. So it does the same logic again, goes through each element, finds the count. Whenever it is 1, it does the job again and just returns back. So that's it. I hope that is clear. I'll submit this. Submit code. Missing number. I'll copy this. Everything is there, right? Yeah. Submit. So that's accepted. Oh, missing number. Yeah, fine. Duplicate number. You have been given an array of size and which contains numbers from 0 to n minus 2. Okay. Each number is present at least once. Among this, there is a single integer value that is present twice. You need to find the duplicate number present in the array. This is so easy that it's just one change away in our previous code. Let me just copy it and paste it. Find the duplicate number. See, I just changed the count from 1 to 2. That's all. Let's see if it actually works or not. G++, find duplicate number, paste. The output is 7. Now let me give the output should be 1 and 3. Yeah. See, what's happening is it's the same question. The framing is a bit different, but essentially what it's saying is here I'm going to give you an array. There is one duplicate element, which means that all the elements are unique, which means if we count the same occurrence count, everything is going to give 1, but there is only one element that is going to give 2. We want that number. It's That's the reason we did it. It's the same logic. We go through the array, have in each iteration we are going to have one element as a target. We are going to count how many times this target element is, and if it is 2, we'll return just print it and return back to this again. So it's as simple as that. I'll just submit it. Find duplicate number. Yeah, that's accepted. Find duplicate number. Next one is intersection of arrays. You have been given two integer arrays of size n and m respectively. You need to print their intersection. The first line contains integer t, a number of test cases. For each test case, the first line contains an integer and size of the array. The second line contains n integers. The third line contains an integer m, the size of second array. The fourth line contains m integers. For each test case, print the intersection in one line. Each element must follow the order they appear in the first array. It should follow the order that they appear in the first array. That's very important, because like if you see here in this case, you see intersection, if we don't choose any ordering, it could be 1 2 2, right? Like here 1 2 2 are the elements that are intersecting, but here they clearly told that they want it in the order how they appear in the first array. uh, okay, let's take these examples and work it out. 4 2 6 1 2 5 1 2 3 4 2. So how do we do it? Let's start with this. We pick two, we compare it with each element in here. It's not matching, it is matching, so yes. Then we pick 6, we won't find it here. Then we pick 1, it's matching, so we would print it. But the tricky part is with these two. So like here, when we keep comparing, it will end here, but we have already used this. So in case where when we have 2612 and 1342 as input, let's assume we don't want two twos, right? Mm, how to solve this? Okay, let's think of what intersection is. The earlier introduction of intersection for us is through sets. So here in this case we have 2, 1, 2, 3, 4. Okay. Um, what I can do is have another array which contains indexes of the elements that are matched in in the second array. So let me rethink from scratch. So here we have a 2. Okay. So I'll have an array which maintains the indexes that I shouldn't touch again. So I'll start with 2, keep comparing. I find it here. I'll store this index in this and see out 2. When I come back, I'll compare this. I won't find it, so no worries. When I come back again here, I'll when I found a match, I'll also check if this particular index is present in this array or not. If it is present, it means I already used this element, right? So I wouldn't use it again. I'll keep continuing the search with these elements. But for one, as we know, like we haven't used it, um, we'll be actually printing it and see out 1, and I will be adding it to this array. Okay, fine. Now we have these two used. Now we get another 2, we compare it, it doesn't match. We compare it, this time it matches. So when we check, this index is already present in this array. So we need to skip it and go further. So compare more. And just because we have it here, we'll print cout 2 and add this index, which is 4 here. And our array is complete and we have it in the same order as it is in first array. This is my logic here. Let's try. Oh my god. I did share the screen, right? I think I changed it only when. No, I didn't share. I didn't share. Yeah, but it is what it is. Like, I don't have the energy to repeat it again. I think you'll understand when I code it. Let's focus on the solve function at most intersection of arrays. So for each input we have first n, then the array of n, and next m, then array of m. So we have these inputs int n comma m. First take input of n, then create an array arrn of size n, then write this classic for loop of n times with I incrementing those many times. Cin arrn of I. Next we input m and do the same. Here we input m. This will make it as array m of size m. With this we have all the input. We just did input till now. So now what we can do is start the actual logic. So what's our thought process? We need to loop through our first array, compare it with every element in the second array, and whenever we find a match, we compare it with another array which we build to just avoid duplicates. So let me write like this. I'll create a vector for simpler use. Vector int used. I think I need to import this hash include vector. So this used is going to hold the elements that we have seen already. For int I equal to 0, I less than n, I plus plus. I equal to 0, I less than n, I plus plus. This is the outer loop. So int target equal to arrn of I. So we have the target element here. So we need to check the inner loop. Int j equal to 0, j less than m, j plus plus. If array m of j, that's the individual element in m array, right? Double equal to target. So this is checking the equality of it. So whenever we find that, what are the things that we do? One thing is we need to see out that element and give space separated see out, and we need to add this index to the used array, use dot pushback of p, not p, j. But again, one thing here, we need to also check something else. It's just not uh, we need to check if j is not present in used. J is not present in used. Only then we do this. So if this is the main condition, once this is solved, we need to check, okay, for bool is found equal to false. For int p equal to 0, p less than use dot size p plus plus. If j equal to use of p is found equal to true, break. So if j is there, is found becomes true, and we, if not is found, if only j is not found, we'll do this part. Print the target and push back this j. Makes sense. Just a second. uh, Use dot pushback of j. Let's test this out. Is it ready? Is found true. We are printing the target with a space. Okay. This is the for loop. This is the inner for loop. So after this for loop, we need to see out and L. uh, Let me test it out. G plus plus intersection of array dot slash a dot out. Let me give a simple input, this one. paste. It messed up. It gave 212 to 21. Why? 221. 221. Bool is found equal to false. For p equal to 0, p less than use dot size p plus plus. If j double equal to used of p is found true and I'm breaking it. If I don't have it, I'm printing the target and pushing it back. 212. Okay, I'll write a C out here that might give me some insight. Z uh, match found. Okay. One match found. One match found. Four match found. Four. Okay, 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 okay. Wait. Okay, okay. So I get it. I get it. This first two is comparing with this one first and also comparing with this. I need to somewhere break it. What? I can break it here, right? Yeah, I can break it here. I understood what happened. I'll explain. I'll comment this out and test it again. Yeah, 212. I got it. I'll give the other test case. 2, 4, 3, and 10 must be output. Yes, perfect. So what happened is just because I didn't put a break here, what happened, um, the mistake that happened is that these two first compared with this got printed, updated the array with the index 1 as the indexes are 0, 1, 2, 3, 4. Then it also went ahead and compared with, got printed again and updated the array with index 4. So this got compared and got printed and updated again. When this came, it did match with this and this, but as we are checking if it's already there in the array, it didn't match. and didn't print. So we got the output as 224, 221 like this. But we were clearly asked to print it in this order, right? So yeah, that's the reason when I added break. So when it was found in the first place, it did break and didn't compare with the fourth elements in the first pass. And when this came, it got compared with this fourth index one. So that's solved. I'll just test it out. I mean, sorry, I'll just submit this. And I am a bit skeptical. Okay. See, the test cases, we have only 1,000 and 1,000. So even then, I'm a bit skeptical that I might get a TLE for this. Let's see. We only have 1 second for this to solve. Let's see. It's taking a lot of time to run. Seems like that got accepted, maybe. Yeah, it got accepted. Okay, intersection of arrays. Not this. So I'm dull till here. Let's continue after a short break. Okay, I'm back. So we have this pair sum. You have been given an integer array of size n and a number x. You need to find the total number of pairs in an array. It's sum to x. Two pairs are considered if they involve different indices of the array, even if the values are the same. The first line contains an integer t, the number of test cases for each test case. The first line contains an integer n, the size of the array. The second line contains an integers. The third line contains an integer x. Here 6 1 3 4 2 5 3 4. Let's write it down. 9 1 3 6 2 5 4 3 2 4. This is 1 2. Two pairs are considered if they involve different indices of the array. 3 4 5 6 7. Is this it? So I'll show what I have written. Okay, you see, if we consider 1, this is one pair. Next, if we consider 3, this is second pair. Again, this is going to be third pair. If we consider 6, it's same, right? Again, 1 6. So there is no another pair with 6. If we consider 2, then it's going to be the fourth pair. But if we consider 5, it's going to be the same thing. It's like we can only keep checking towards the right. We need not check what's in the back side. So if we consider 4, this is the fifth pair. No, wait. If we consider 5, we have one here. This is the fifth pair. If we consider this is the sixth pair. If we consider 3, this is the seventh pair. Our answer is 7. Let's check for other inputs also. This is very crucial to understand how this is going to come for us to write the code. 136254324. Here we want the sum to be 12, and in another case 6. 2, 8, 10, 5 minus 2, 5. Okay, the first line contains integers. So the second line contains n integers. The third line contains x. Okay, but okay, makes sense. Okay, let's see here. The sum should be 10. So here if we move from left to right, no 1, we don't have a case where we get 10, 12. Wait, if we take the top two numbers itself, the max sum is 11. Here there is no way we can have a sum of 12. So it just does all the comparisons. It just does all the comparisons and finally leave it. Let's do this. We'll compare 2 with 8. That's one pair. Is there any way? There is no other way. Next, 8 with anything? No. 10 with anything? No. There is another 5, 5. Is it? That's it. Yeah, 2. We have only 2 pairs. So, makes sense. So, the goal is that, like, the logic is that we take the element in the array and compare it with, see, if we choose 2, we want to find 8 because our target is going to be this 10 minus 2, which is 8. We are going to count occurrences of 8 here. In this case, that's 1. So we'll add 1 to our final result. And next we'll pick 8. When we have 8, the target is 2. Target is 10 minus 8, which is 2. We don't have a 2 here. Then we'll do 10, then we'll do 5. As we got here for 5, we'll get to the second pair available. So yeah, that's the logic. We pick we pick each element, find the target and search how many times that target is available in this remaining array, and we keep doing it by selecting each element and checking till the end of the array. That's the logic. Let's try to implement it. Pair sum. Dot cpp. We'll obviously do it for one thing first and then we can think of writing this loop. So here we, for every input, we are getting the array first. So we are getting the array size first, then the elements, then the target value. I mean to say the X value, which we want to get sum for. So creating an array of size n for int I equal to 0, I less than n, I plus plus cn array of I, and then int x, cin x. So with this we took all the inputs. Now it's time for us to find the actual result. So for int I equal to 0, I less than n, I plus plus, because we want to loop the array completely, right? So our current element is array of I, but in the remaining part of array, we want to find the target. What is target? The target is x minus current element. So if we want 10, if we have 2, we need to find 8, right? That's, we want to pair our 2 with 8. That's the thing we want. So what we need to do for int j equal to I plus 1, because we want to start from the element right of the current position where we are, and we need to go till the end of the array. So that's going to be till n by incrementing by 1. That's why j plus plus. So what must happen here? If this current element, whatever we are searching again in the inner loop, is the target, so it means we found a unique pair. So what we do? Result plus plus. Because at the end of the day, we were asked only the count of number of such targets, right? Um, I think that is it. See out result end line. And this one, we are taking the number of test cases and just calling the solve function each time. Let me take this input and run it. G++ pair sum. I made some mistakes. What are those? Okay, my array name is ARR, not A. What else? Okay, another variable name mistake. Yeah, yeah, the output is 7. This output should be 0 and 2. Done. Let me select the problem, paste the code, submit. Accepted. Pair sum. Triplets. You have been given an array of size n and a number x. Find the total number of triplets in the array with sum to x. Two triplets are considered if they involve different indices of the array, even if the values are the same. This is a similar problem, but the only thing is, the only difference is, uh, one second. Yes. Similar problem, but we have three indexes here, which means we can add three numbers. Let's see how it pans out. I'll write few test cases and then share the screen. 7, 1, 2, 3, 4, 5, 6, 7. And the required number is 12. Let's see how that happens. And another one is 9, 2 minus 5, 8 minus 6, 0, 5, 10, 11 minus 3. 280, 211 minus 3. I'm also noting down the solution for this so that I can verify later. Okay, so here let's solve this one first. We want a sum of 12. As usual, we go through this, and I think we need to have three loops here. Like the first loop rotates through all of this, then in the inner loop it starts from the next element and goes through all of this, and in the deeper element it goes through all of this. So we'll be checking 1 2 3, 1 2 4, 1 2 5, 1 2 6, 1 2 7. Then this, as this loop goes here, we'll check 1 3 4, 1 3 5, 1 3 6, 1 3 7, and then 1 4 5, 1 4 6, 1 4 7, then 1 5 5, 1 5 6. Oh, sorry. 1 5 6, 1 6 7, then 1 6 7. Then it go to 2. It repeats the whole process. 2 3 4, 2 3 5, 2 3 6, 2 3 7. Then 2 4 5, 2 4 6, 2 4 7, then 2 5 6, 2 5 7. Then 2 6 7. Then it goes to 3, 3 4 5, 3 4 6, 3 4 7, 3 5 6, 3 5 7, 3 6 7. Then it goes to 4, 4 5 6, 4 5 7, 4 6 7. Then it goes to 5. Then it does 5 6 7. So it adds all this and compares to find when the sum is equal to this 12 and gives its count. That's all. That's all. So we need to write three loops. the first loop starting from I equal to 0 till n. Next loop j starting from I plus 1 till n. K starting from j plus 1 till n. Done, 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 done. I think that's it. Let's code it up and see. So for each input we have, it's a similar one. So I can just triplets. I'll copy this triplets. So here we need to introduce another loop. There is no target. Let's forget what target is. We don't need this also. We just have to write array of I plus array of j plus array of k. Here we'll introduce another loop int k equal to j plus 1, k less than n, k plus plus. Uh, int we'll write sum equal to array of I plus array of j plus array of k. If sum double equal to x, result plus plus. That's all. That's all. All we did is before we have two loops, now we have third loop, and each time we are accessing different indexes as I have shown here. It's different index each time. Every single time we'll add the actual elements from these indexes and find the sum. If that sum is our target, we'll do result plus plus, and then we just print it out. Let's test it out. Triplets dot slash a dot out, paste. I get 5. I get 5. And then this 0 5. Done, bro. Done. It's done. I'm sure. Triplets. I still have one more problem to finish this arrays concept, and I can move on after taking a longer break. Um, did it work? Okay, it's still running. Running on test 10. It should work. Accepted. Yeah, I told you, no. What did I tell you? Next one, the final one. Count quadruplets. You are given an array A of length n and n in here. Your task is to count the number such that, okay, this is what we need to check. Got it. Got it. It's just the same. It's just the same. Okay, okay. I'm here. Count quadruplets. It's just like this. We'll introduce another array. Instead of checking the sum, we'll use the equation they gave there. Count quadruplets. This is the equation. I'll write it in a comment here. We, instead of this, add another loop where it's k plus 1, l less than n, l plus plus. But here the sum must be like this: array of I plus minus 2 into array of j plus 3 into array of k plus minus 4 into array of L. That's it. So see, that that's the same thing that's asked. We want to find the um, how do I say? We have indexes like this, and for which index we have this value like this, we are selecting that. The only difference is that we were provided the value earlier. So the x is being given to us earlier. So before taking input of the array, we need to take input of x. That's the only difference. And I think we are good to go. Let's test it out. Okay, and another thing, there is no t number of test cases and all we need to do here is just remove everything, call the solve function once. That's all. G++ count quadruplets. We'll copy this dot slash a dot out, paste. We got 1. Yeah, the output is 1. And we'll do this. The output should be 5. Yeah, the output is 5. Cool. I think we are done. We are so done. Oh, what emoji? I don't have any emoji in it. Oh, there is something wrong here. I'll just remove this for safety reasons. Command C. Hmm. Okay, now I'll take a longer break. We are done with arrays. Um, we'll go to groups again. So this is done. Uh, Actually, I didn't participate in contest 2. I was uh, away for some reason. I'll do a virtual participation right when I come back. And yeah, from then we'll continue the other things. Uh, Actually, I need not do contest 3 because I participated in it. Mm, yeah, I got the 16th rank in that. I haven't seen what the problems are in contest 2, so the part after I get back will be exciting, like very exciting. I'll just take a good break and come back. Then next we have 2D array strings, sorting and searching, mixed practice, time and space complexity. Okay, long break. Can't I edit it? Okay, not this. I'll take a long break. I'm back. Let's start this again. Actually, I don't need this for now because I'm going to enter the contest and there won't be any breaks in between. I won't be explaining as much like before because it's like a timed one, right? Of course, it's a virtual participation, but yeah, it is what it is. Okay. Russia. 10 seconds more. Okay, let's see. Result day, it's result day. This is distracting. I'll stop the music. Okay, it's the result day, and you are given the marks of n students in a class and the passing marks. The student is considered if their marks are greater than or equal to the passing marks. Otherwise, the student is considered failed. Your task is to count how many students passed and how many students failed. Okay, number of students, marks of students, passing mark. Print exactly 2 lines, pass, fail. Okay, result day. Result day dot cpp. Let's see what the input is. Input is in this format n, the array, and then the pass mark. As include higher screen using namespace std int main int n cnn, taking the input of the size int array of n, taking input of the actual array int I equal to 0, I less than n, I plus plus, cn arr of I, taking pass mark cn pass mark. But the question is greater than or equal to, right? Okay. We'll take another variable in pass count equal to 0. We don't need a fail count because once we have the pass count, if we subtract n with the pass count, that's the fail count. So we'll just loop through the loop array, and we'll just check this. If array of I greater than or equal to pass marks, pass count plus plus int fail count equal to n minus pass count. So what's the output format? It's like this: pass equal to 3, fail equal to 2. So cout pass, there is a space, and then we have pass count, then there is fail, and then there is fail count, but in between these two there is an end line because fail count is coming in the second line, right? Or I can just write it for clarity: cout fail count. Seems that is it. Yeah, I'll test it out with this. Pass 3, fail 2. Yeah, that's it. I'll submit this. This is accepted. Result today. Fastest runner. In an Olympics race, there are n runners numbered 1 to n. You are given the time taken by each runner to complete the race. The runner with the minimum time is considered. If multiple have the same file, choose the runner with the larger ID. Larger ID. That's important. Um, yeah. Okay, makes sense. It's just that minimum number only fastest runner. We'll just be taking input like this. Yeah, that's the whole input, the size of the array and input of the array. So we'll find min equal to 10 power 9. I'll assume the minimum to be array of 0. Anyway, the array will definitely have one element as per the question. For int I equal to 0, I less than an I plus plus, and I also need to maintain min index because that is the one that I should print. And is it 0 based index or 1 based index? ID of the fastest runner. So here the answer is 9, 1, 2, 3, 4. So it's 1 based index. Min index equal to 0. We were not told what to do when we don't have an answer, right? Okay. If array of I is min, less than or equal to min equal to array of I, min in equal to I plus 1, because we want the position, not the index. Min in G++ fastest runner dot cpp. We should get the output 9. I mean 4. Yeah, that's done. My internet connection is fine. Yeah. Okay. Sort 0, 1, 2. You are given an array contains only the value 0. Your task is to print array in descending order. This is pretty fine. Sort 0, 1, 2. We have recently done sort 0, 1, which is like we count each element count and just print those in the way it's asked. So it's just same input, taking input of an array. Here we'll have three variables: int count 0 equal to 0, count 1 equal to 1, count 2 equal to 2. Sorry, 0. We, these counters will initialize with 0. So we'll loop through the array once and keep maintain these counts. If array of I double equal to 0, C 0 plus plus. Double equal to 1, double equal to 2, 1, 2. So by the end of it, we'll have how many times we have 2, how many times we have 1, how many times we have 0. Now it's just time to print, that's it. We print with space separated. First we print C2, C out, 2. We'll separate it with a space. Then we print C1 and then C0. This is 1, this is 0. That's it. Let's test it out with this input. G++ sort a dot out, give the input 221100. I'll give my own input 7 0 0 0 0 4 1 2 1 2 1 1 4 zeros. That's very good. I'll submit. Sort 0, 1, 2. Accepted. Compare factorials. You are given two non-negative integers a and b. Whether a factorial equal to b factorial for a non-negative integer, and the factorial of n is defined as, by definition, 0 factorial, a single line containing two integers a and b. See, if the both numbers are 0 or 1, I mean, like, it only works for 0 1 1 0 1 1 0 0. That's all. And if a equal to b, in all other, simply I can say one of, if a equal to b, or a0 b1 or a1 b0, that's the case of yes. That's all. Yeah. Compare factorials. .cpp. Just input two numbers. Int n comma m, int n comma m, cn n m. If n double equal to m, or n equal to 0 and m equal to 1, or n equal to 1 and m equal to 0, print yes, else no. G++ compare factorials dot a dot out 1 2, no, 1 1 5 5 5 6 5 4 4, yes, 0 4, no, 0 1, yes, 1 0, yes, it's done. Compare factorials. Oi, wait. Wrong answer on test 7. Okay, let's check. Oh, if both are zero, even then, for non-negative integers, your task is to determine a factorial equal to b factorial. A single line contains two integers a and b. Print yes if otherwise print no. Even if both are zero, the if condition satisfies. Both are one, the if condition satisfies. Plus compare 0 0, yes, 1 1, yes, 2 2, 0 2, 0 1, 1 0, 1 1. I don't find any issue in this. The range of A and B is from 0 to 10 power 18 only, right? Mm, okay, let's see again later. I'll mark this as unsolved. For now, I'll get back to this. Beautiful array. An array is said to be beautiful if all elements are equal. Given an array of integers, determine whether the array is beautiful or not. Beautiful array dot cpp. We take array input. We'll definitely have one element. Int element equal to array of 0. We'll just count the occurrences of this element. If that is equal to array size, which means it's a beautiful array. Int c equal to 0. Y, for int I equal to 0, I less than n, I plus plus. If array of I double equal to element c plus plus. If c double equal to n, then it's beautiful array. If in the else case, it's not a beautiful array. Yes and no are capital. C out. Yes. C out. No. This is done. Wait, what's happening? Oh my god. Simple mistakes that would have added to my penalty. Accepted. Yes. Special factors given an integer and print all special factors is often in increasing order. A factor is called special if the last digit is 2 or 7. Oh, the only line contains an integer. Okay. Just one input n for int I equal to 0, I less than n, I plus plus. If I percent 10 double equal to 2 or I mod 10 double equal to 7, and n mod I, wait, okay, we can't divide with 0, I less than or equal to n mod I double equal to 0. This is the whole condition. Fact equal to I, C out I with a space. After the for loop, if fact double equal to -1, which means there is no factor at all, we just print it. Eighty-four, 27, 12, 42. Okay. Yeah, seems like we did it. Let's see. Accepted. Special factors. RCB wins again. After winning the IPL, RCB is posing for a victory photo, but instead of standing in usual, the captain wants a format that feels perfectly symmetric. The arrangement defender start from the two middleware, then move one step outward on both sides, print the next outward player, continue until all players are included. It's given that we will always have n as even integer itself. This we need some discussion on. 10, 20, 30, 40, 50, 60. 10, 20, 10, 20, 30, 40, 50, 60. Middle minus left, right. Left, middle, right. Left side, right side. Okay. Here we have n equal to 6 and these indices as 0, 1, 2, 3, 4, 5. N equal to 6. N by 2 minus 1 will be our left one, n by 2 minus plus 1 will be our right index. We can have it as it's definitely even. What we can do is we can write a loop for int I equal to 0. We can write int half equal to n by 2. In this case the output will be 6, which will be 6 by 2, which is 3. Half will be 3. I less than 3. I equal to 1. I less than or equal to 3, which is half. I plus equal I plus plus. Here what we can do is C out, or simply left equal to half minus I, right equal to half plus I. Does it make sense? No. Half plus I minus 1. Then we'll see out array of left, array of right, left, right. Okay, but let's see when how I changes. Initially half is 3. Half will always be 3. When I equal to 1, left will be 2. Right will be half plus I minus 1. This time it will be 3. When I is 2, half will be 3 minus 2, which is 1. And right will be half plus 2 minus 1, which is 4. When I is 3, half will be 0, left will be 0, right will be 3 plus 3 minus 1, which is 5. So you see we are covering the elements exactly how we need. Yeah, it's done. Let's code this. This became a bit easier because we were given that n is always even. Okay, RCB wins again. So what's the input here? It's like input of an array. We can take this. We have the array now. So what did we think? We thought half equal to n by 2. This will, for int I equal to 1, I less than equal to half, I plus plus, int left equal to half minus I, int right equal to half plus I minus 1, Cout array of left space array of right. So in one iteration itself will print two elements. That's why it's enough for us to run half the loop. So 30-20 will print once, 20-50, 30-40 will print once, 20-50 will print once, 10-60 will print next. Let's test it out. C++ RCB wins again. A dot out, paste. 30-40, 20-50, 10-60, perfect. Submit. It's accepted, accepted. Almost primes it seems. A prime number is a number that has exactly two divisors, one and the number itself. A number is called almost prime if it has at most four positive divisors. The only line containing an integer and print all integers x such that and x has at most four divisors. Print them in increasing order separated by single spaces. Okay, I'll write a divisor count function, almost primes. CPP just input n. What I'll do is, what do we want for all numbers from 1 to n? For int I equal to 1, I less than equal to n, I plus plus. If divisor count of I at most 4, less than or equal to 4. Cout I with a space next to it. Now I need to write this divisor count function int div count of I int I for int I equal to 1, I less than 1, I uh, let's take j for j equal to 1, j less than I, j plus plus What do we want? In int c equal to 0. By the way, let's write equal to I. C plus plus, because while counting divisors, the number itself is also a divisor, right? Return C. I think this is it. I don't know what happens when the test case is very big. I did a mistake somewhere. Just a second. Line 17 and 18. Oh, why did I write for 2 times? My bad. It's small and bro. I messed it up very badly. Has at most 4. At most 4 means less than or equal to 4. That's it, right? Why is it not printing anything beyond 4? Okay, I need to take something. Int div count equal to C out I space div count and line div count. This will give me more clarity. What? Oh, my bad. DC. Why for 4 it's 5, bro? Why for 1 it's 2? J equal to 1, j less than or wait. For 1 it's 1. For 1 it's 1, we print 1. For 2, 2, 3, 3. Yeah. How for 3 we are getting divisor as 3? Okay, I'm an idiot. I didn't do anything here. I'm just straightening the number back. If I percent j double equal to 0, C plus plus. This is greatness overloaded. Yeah, that's it. Now I can remove this. Nothing breeds a print statement debugging. Yeah, it's done. Almost primes. Almost primes. Oh, it got accepted. Unique elements. You are given an array of integers. Your task is to print all elements that occur exactly once in the array in the same order as they appear in the input. This is very easy. Unique elements. Dot cpp. Will take input of an array. Well, write. Don't want to write a function. I'll just write it here itself. We'll go through each element of a array once. For I is equal to 0, I less than n, I plus plus. We'll start a counter. We'll count how many times each this particular element is repeating in the array. So array of I, target equal to arr of I. For int j equal to 0, j less than n, j plus plus. If array of j double equal to target c plus plus, if c double equal to 1, c out target with a space. That's all. Huh? That exact only once in the array in the same order as and separated by thingy. If no such elements, print an empty line. Yeah, that's all. See out end line. If there is nothing like this, this serves as the empty line. Or I'm not sure. Let's see. Unique elements dot k dot 1 4. This is also fine. Yeah, let me submit it. Got it. Unique elements. This is also done. So only one left in this contest. That is it. So here it's very simple, but I'm missing something, something, a very small thing. You are given two non-negative integers A and B. Definitely the numbers are going to be non-negative. Your task is to determine whether A factorial equal to B factorial. For a non-negative integer n, the factorial of n is defined as n factorial equal to 1 multiplied 2, 3, so on n. And by definition, 0 factorial is 1. What case am I missing, bro? What case am I missing? Where is the special? Compare factorial. N equal to m or 0 1 or 1 0. Is there any other case where it's an s? Is there any other case where it's an s? 0 1 1 0, n equal to m. 0 1 1 0. 0 2 is also not a thing. But why? Mm, you are given two non-negative integers A and B. Your task is to determine whether a not of the factorial of n is defined as 0 factorial is 1. 0 factorial is 1. Print no. Yes, no. It was so clear. And why did that particular test case fail? Is there any more details? Wrong answer on test 7. What's this? Okay. Okay. This is the same thing. Compare what? No. Wrong answer on test 7. Wrong answer on test 7. Compare factorials. In yes, if a factorial equal to b factorial, otherwise no. You are given two non-negative integers a and b. Your task is to determine whether. By the way, how long do I have? Is there a timer running? Okay, I still have an hour to finish this. You are given two non-negative integers a and b. Your task is whether a factorial equal to b factorial. G plus plus. Compare 1 5. No. 1 0. Yes. 0 1. 5 5. 0 0. Yes. 1 1. 1 2. 300. 300. 399. 399. 0 399. Bro, yeah, I think mine is right, but wait. A B can be from 0 to 10 power 18, bro. 10 power 18. Long, long. I think that's it. I think that's it. I'll give a very big number. In the previous one, beyond the range of hint. It's definitely beyond the range of hint. There is the problem. Yes, it's definitely about uh now let me give. Yeah, that's the problem. You see, like sometimes the solutions are in small details that we often fail to acknowledge. This will be done. This will be, yeah, test case 7 ran. That's it. It's done. It's done. It's done. It's done. Oh, this is roughly I am like 47th, 45th rank. I have wasted much of the other one was wrong just because of case sensitivity. Yeah, like we get it right most of the times we make silly mistakes just because we don't look at the details properly. Attention to detail is very, 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 very important. So contest 2 is also done. We'll start 2D arrays with a break. I mean, post a break. Still have 50 problems to do. Row order, column order, find the maximum, search in 2D matrix, row minimum, column sum, row with max funds, wave 1, wave 2, boundary traversal. Okay. What's after 2 DRS? That's strings. We'll after my break is done, we'll do 2D arrays and I'll stop the live. I need to revise these two before we solve this. So once I start the next, what do we say, next live, we'll finish all these remaining strings, sorting and searching, mixed practice, and time and space complexity. And I need not do this because I already participated in this. Yeah, that's the 16th rank. Okay, that's all. I'll take a break and get back. I'll continue. So now it's 2D arrays. You're given a 2D array of size and cross m containing integers. Your task is to print all the elements of the matrix row by row. Okay, it's just saving the input and printing the elements. Mm, Instead of week number, I'll write the topic name. That makes more sense. And this is bi-weekly contest 2006. Yeah, that's all. So CD 007 code space dot. Let me close others. Actually, this is easier, right? I need not juggle between tabs. Yeah, it's easier. It's much easier. Glad. Okay, row order. It's just how we take input itself. Row order dot cpp. So here we are given a matrix of size n cross m. So that is like matrix, right? See, n rows 0, 1, 2, 3, m columns 0, 1, 2, 3, 4. Okay, so this we represent as int array of nm, and we take input using two loops I from 1 to n, and inside it we take for j from 1 to n, or more technically we can write from 0 to n minus m, 0 to m minus 1, the indexes, and we'll just access array of ij c in the same way. While we want to print this cin, we will change replace with cout, and all we do is this and separated by space, and after each row we'll do cout end line just to go to the next line. This is pretty easy and makes sense when we write the code. Actually, I can leave it like this. Okay, first the input, it's n and m, and then the next analyze contains m integers. Yes. Ash include IO stream using namespace std in main and in this we need to take input of n comma m first, cin and then m for int I equal to 0, I less than n, I plus plus, for int j equal to 0, j less than m, j plus plus, cin array of I j. You know what the best part is? We can write the cout here itself, but let's not do that. It becomes messier. But I doubt it actually. It's better to write cout like this. Cout, and after each element we give a space, and after each row we go to new line. That's it. Oh wait, did they ask, what's this? What's happening here? Okay. No, they didn't ask this new line. Everything is getting printed in a single line, so we don't need that. Clear G++ row order. What did I miss? Oh my god, I didn't initialize the array. Int array nm dot slash a dot dot 3 3 1 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9. Yes. Oh, copy. I didn't copy it properly. Now I'll paste it. 37105826491932740856 23714. Nice. I'll submit this. Done. Uh, Row order. Column order 147258369. You see, we are accessing the columns first and then going through each row. So first we print all rows of a single column. So for that, all we do is this. First we write the column. See here what happens in the first row, first iteration. J equal to 0, I goes from 0 to n, which is 0 0 1 0 2 0. Next J is 1 and then I goes from 0 1 1 1 2 1. Similarly the second index. Let's just test it out and see if, oh, I changed the code of row order, column order. Row order is just like before. Yeah, this is correct. Let's leave it. Let's go to column order and run this. See, 147258369. We got it exactly. Let's test it with this 63192745806345271980. Done. Yes, let me submit this. Column order. Find maximum. You are given an integer maximum of size and cross sum. Your task is to find the maximum element in the entire matrix. You are given an integer matrix of size and cross sum with a maximum of the entire matrix. Fine. It's just that we need to access each and element and see which is great. Find maximum dot cpp Paste this code. See, till here it's just taking input. So we'll write a variable int max, and I'll start this with -1 because in the question our values of each element is starting with 0. So I'm just starting a step behind it. And if ARR of I say is greater than max, max equal to ARR of I say, that's it. See out max, that's it, that's it, that's it. G++ find the maximum /a dot out 9, done. /a dot out, give this input. Here also it's 9. Yeah, done. Let's admit this code. C, find maximum. Find maximum. It's accepted, access, accepted. Search in a 2D matrix. You are given an integer matrix and index. Print true if exists in the matrix. Otherwise print false. It's we can use the same code but modify it. Search in 2D matrix .cpp. See, we also have input of a target element here. So this is X and M and X. So here we'll take a boolean of is found. We'll have it as false because we can make it true when we find it. If this is equal to X, the target value, all we need to do is is found equal to true, and as we found it we can just break from here and just see out is found. So what happens if it's not there, it loops through all of this and this if condition never gets triggered, and finally is found false will be printed. G++ search. I'll copy this. Okay. The default printing prints booleans as integers. So I have to do this if condition. If is found, cout true, else cout false. Paste true. This should be false. Yeah, it's false. Yeah, I'll submit this. Okay, submit code. D search for a 2D matrix. Search in a 2D matrix. It's accepted. Row minimum. Row minimum dot cpp. Let's see. You're given an integer matrix. Okay. Your task is on the minimum element of each row. Cool. Uh, let's use this. Here we want minimum of each row. So it's like, see here, till here we have taken input. Here we don't want this. We'll initialize inside of each row. Okay. So this is how we traverse each row. And what we do is we take int min equal to the maximum of this number is 10 power 5. So I'll take that 10 power 5 if array of I j less than min equal to array of I j. Now what I'll do is after each row, so when we exit out of this loop, it means that row is done. I'll just see out min and separate it by a space. That's all. Let's test it out. G++ row min 147. Yes. 02011. Yes. Yeah, that's accepted. Column sum. You are given an integer matrix and your task is to complete the sum of each column. Earlier we printed with each column, right? We can directly make use of it. Column order, we can see here we are accessing each column. So this inner loop is one column. So if you see like 7 plus 4, 11 and 1 plus 1, 12. 8 plus 2, 10 plus 5, 15. That's I don't need a break. Let's me start again. So it's the sum of each column that we are printing. So here similarly what we'll do is int sum equal to 0, and each element of this array what we'll do, each element of this column what we'll do, we'll add it to the sum. But again, one thing, 10 power 5 or 10 cube, 10 power 8. Okay, it will be integer range itself. We'll just see out sum with a space for each column. That's all. That's what is asked. G plus plus column sum dot slash a dot out. Let me give this input. 12, 15, 18. It's exactly what was there. 1922, 1922. So yeah, this is also done. Submit code, column sum, paste, submit. It's accepted. Row with max funds. You are given a binary matrix of size and crossover. Your task is to find the index 0 based of the first row that contains maximum number of ones. The first line contains two integers. Contains m integers. Print a single integer, the index of the first row with maximum number of ones, or minus one if no such row exists. This is important. Row with max funds dot cpp. So here again, the first part is just taking input itself. We'll take row order because here we are accessing again by rows. Okay. So here, what I'll do is int max ones row equal to -1. Int max ones count equal to 0. So here in each row we need to count the number of ones. So we'll have a counter starting when we start each row. And what we do is if this array, I mean like this matrix element that we are currently accessing, if it is equal to 1, we'll lose just C++. And by the end of this loop, we'll get the number of ones that are present in this current row. And if this C is greater than max one's count, the global counter, index of the first row with maximum number of ones. Yeah. If C is greater than this, then max ones count is equal to C and we want the index, and max one's row equal to what index it is. It's ith index. And as they asked zero based, it's fine. Finally, what will we print? C out max one's row. That's it. Let's try. Yeah, we got one for this. We need to get 0 for this. We got it. We need to get -1 for this. Got it. So we wrote this -1 because if this doesn't satisfy at all for any row, we were asked like if it doesn't satisfy, we need to print -1. That's the reason I initially took it as -1. Let me submit this code. Wave 1. You are given a 2D array of size and cross-sum. Your task is to print all elements of matrix row by row in waveform. Print the first row from left to right and second row from right to left and so on. Yeah, wave 1. Hey, did I update the sheet for the previous one? No. Row with max ones. Now wave 1. You are given a 2D array of size and cross-sum. Yeah. First row it's left to right and then right to left. So basically we can say like if the row index is divisible by true, index I'm saying, not position, we'll go left to right, else we'll go right to left. I'll do that. I'll start with row order. See here we are inputting array and we just have one way to print it, which is from left to right. But what we can do here is if I percentage to double equal to 0, we can do this. Else we print in the opposite direction, which is j equal to m minus 1 while j greater than 0, j minus minus. It's just that we are changing the order of uh, printing. So initially we'll have I equal to 0, right? So the first row it's going to print left to right, next row it's going to print right to left and so on. That's it. Let's try. 1, 2, 3, 6, 5, 7, 8, 9. Hey, 4 is missing, right? I greater than or equal to 0. Testing is important. 6, 5, 4, 7, 8, 9. Yeah, makes sense. 6284195073146280735 Yeah, it's all good. I'll submit this. Wave 1. It's done. Accepted. Wave 2. Okay. Your task is to print all elements of the matrix column by column in waveform. Print the first column from top to bottom and the second column from bottom to top and so on. I'll take this from column order. Oh, we need to do a similar thing inside this. You see what I did? I need to refine this. This is for the outer loop. This must be the inner loop. If for j equal to 0, else this must be I is equal to 0, I less than n, I plus plus. So see what's happening. J starts with 0, which means the 0 column, as you can see here. First it goes from top to bottom. That's why 0 to n. Next it must go from n minus 1 to 0. I equal to n minus 1. I greater than or equal to 0. I minus minus. That's all. Clear. G plus plus wave 2. Yes, this is the one. A dot out, copy, paste. 147852369. 72914506831037268245. That's it. I'm going to submit it. Wave 2. Yes, this is done. Next, boundary traversal. Here, given a matrix of size and cross-sum filled within you, your task is to print the boundary of the matrix in clockwise order starting from top left corner. 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5. Okay. This is a bit tricky, but it's all in understanding each bit of it, like breaking it down and printing stage by stage. I'll take row order. I'll just delete everything except the array input. Just give me 1 minute. We'll take the input and do it so it's clear. 4 by 4. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So we want it in a certain fashion. So let's break down the whole thing into parts. So first we'll print this 4. Next we can print this 3. Next we can go for these 3. And finally these 2. For all these individual sections, it's important to highlight uh, what part of it is changing and how it is changing. So if we see the indexes, so in this case, like in the green case, I is always 0, j is changing from 0 to 3, whereas in the blue case, j is always 3, I is moving from 1 to 3, whereas in this red case, I is I is constant, which is 3, j is moving from 2 to 0, which is like decreasing. Here it's increasing. Here also it's increasing. In the black case, j is 0, I is moving from 2 to 1, which is decreasing. So here for we need to come up with for loops in each case. So here for j equal to 0, j less than, this is m, right? M minus 1, j plus plus, j less than m, sorry. It need to go till m minus 1, j plus plus. This is the loop here, where inside will write as array of 0 comma j. That gives us our first loop. Similarly, we need to write for each case. We'll have anyway this next to us, we can check and write that. So what's the first thing we need to do? We want to move j from 0 to m because it's our first row. Cout array of 0 and j with a space. Yeah. So one condition is done. Next we'll go with the last column, which is where I is moving from 1 till n minus 1, which is I less than n. I plus plus, it's increasing. Cout array of I, and this would be n minus 1. For int j equal to m, wait, this is m minus 2, j greater than 0, j minus minus, cout array of n minus 1 j, and finally for int I equal to n minus 2 to I greater than 0, because we don't want 0, I minus minus cout array of I, j is always 0 in this case because it's first row. I think that's it. Here I need to add spaces. Let's see. Oh, this is also done. Okay. G plus plus boundary traversal dot slash a dot out, giving this as input 1 2 3 4 8 12 16 15 14 13 13 didn't come, 13 9 5 13, where is 13? Here it is. So this must be greater than or equal to 0. Let's test it out again. Now we have 13. 1 2 3 4 8 12 16 15 14 13 9 5. Let's test with the other input. Oh, I don't think this will work for single. Yeah, Okay, so what happens is for single row, mm, and this would be a problem for single row and single column. That's the special case here. Just a minute. It's the, how do I say, like we repeat it twice because here we process a row, right? Again, when printing back, it's taking the same thing. So what can we do? What we can do is check if the starting row is same as last row. Like we only process uh, the end row only if the start row not equal to end row, and we only process sh- start column only if start column not equal to end column. So these two cases here, if what's the start column, and wait, for j starting at this one, j is starting at m minus 2. This is start row, this is end row. Yeah, if n minus 1 not equal to 0. See, n minus 1 is the index of our last row. 0 is index of our first row. We only process this only if this condition satisfies. Actually, we can write that here itself in the for loop. And here, and m minus 1 not equal to 0. I think that should do with this. Let's see. Yeah, 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5. I think we are done here. Boundary traversal. Wrong answer on test 3. What's that? I'll check this and get back. By this is a great session. Like it's almost close to 5 hours that I did this. All thanks to the anger that was created in me today morning because of the lead code contest. Yeah, thank you. I'll do another live soon.